what we are looking at. It's on the outline on the front of our, on our teams, which I also have a printed copy for you. It's next Tuesday. All right. My breaking point is at 0. My breaking point is at 0. That means that my table should include 0 twice. Numbers less than 0 are -1 and -2. Numbers bigger than 0 are +1 and 2. So the bottom equation is x values greater than or equal to 0, and the top equation is for x values less than 0. Yes? No. Just as long as you know which equation they go to, it doesn't matter. So -2 plugs into x. So -2 plugged into x gives -2. -1 plugged in gives -1. And 0 gives 0. This graph is open and shading to the left. So when I graph these points, it's an open circle at 0, 0. I plot -1, -1, -2, -2. And again, it's going to the left, or the x value is getting smaller. So I go from my open circle and an arrow through my points to the left. The bottom equation says for all x values greater than or equal to 0, the y values are 2. So that means I have the closed circle at 0, 2. And every value from x on will always have a y value of 2. So I have a horizontal line facing infinity on x at 2 for y. My domain is all reals. Yes. Okay, so why is the first 0? Because of the equations right here. So here, when you plug 0 in for x, you get 0. So that's exactly why it's an open circle. So essentially what's happening is that this graph is getting really close to 0, 0, but it never gets there. So the open circle is an implication that the graph is getting there, and then boom, it stops. So like that's why you need that open circle, because you have to show me if you stopped it at -1, -1, you lose all those values from -1 to 0. So no, that's a fair question. It's very hard to explain it. So basically it would be like if I was walking and I get like really close to where I want to go, and then all of a sudden I decide I'm going to jump to 2. Like your graph is jumping over, like, let's say a hurdle to get to 2. I'm not going to jump to get to the closed circle. So, like, as we get into, like, higher and higher math, I call that jump discontinuity. So my graph isn't continuous. It has this breaking where it goes from one function to another. I was joking. I'm going to do that. Not that. But I did almost trip on the board the other day. I stepped on it and I heard the slide. I was like, wow. I didn't stop. Does that help? So the range comes from this idea now too, though. So if I ask you, does y equal 1? Is there any point on my graph where y is equal to 1? No. Does y equal 2? Yeah, a whole bunch, right? So my range is going to be y equals 2, because it happens here. And then, could y be negative 100? Because this graph goes down, right? So it would happen somewhere over here. Actually, it would happen when x equals negative 100. So y equals that. So the idea is that y is equal to 2 or y is less than 0. So it's got to live in one or the other. Because here's 0 for y. And again, the graph is pointing down. So it's going to be y values are less than 0 or equal to 2. Yes. And I'm going to write it. I just have to get back there because I can't write up here. Yeah, I'm going to go write it. I don't have a pen. I'm not in the right mode to write on that. Or I'm sure there is a mode. I just don't know how to do it. So yes, your range would be y equals 2 and y less than 0. Yes.
So are we going to have this help as a function on the grade?
Yes. Now this would be a function. Does it pass the vertical line test? The answer is yes, because this one is open and this one is closed. So that's why I was saying on your homework, you can't make both of these closed. The only reason it would ever not be a function is if it's equal here and there.
Now, if you're graphing this and it's an open and a closed circle, but when you graph it, it takes over the open circle and becomes a closed circle, would that not be a function?
It would still be a function because they meet at the same point. So, like, yes. But if they would meet at different points, then the answer would be no. Like if, yeah. Yes, Sophia? Yes. All right. Letter H. So now, where's my breaking point? No, he's right. There's 1 at 1 and where? -1. So this does not have a domain of all reals because there's an area where there's no graph. So you have a breaking point at -1 and at +1. So the -1, -2, etc. are all going to be at 3. At -1, 3, is that point open or closed? Open. Good. Yes.
The circle, like the open or closed circle, is always where the breaking is, right?
Yes. Okay, and then we have x equals 1. So 1 plus 1 is Good. And then you have 2. 2 plus 1 is. And then if you did 3, you got 4, etc., etc., etc. At 1, 2, is my point open or closed? Open. Oh, am I 1, 2 right now? 1, 2. Okay. 2, 3, 3, 4, etc. See how the domain is not all reals though, because there's no graphs from -1 to 1. So your domain, you could actually just write the inequalities up here. X less than -1, x greater than 1. If you like the infinities, it would be like -infinity to -1, 1 to infinity. There's a hole from -1 to 1. This is still a function because it still passes the vertical line test. What's my lowest y value? Okay. What? Yeah, what's my highest y value? Yeah, and then, but what's happening with the graph in the corner? It's going up. So what's my range? Yep. Okay, where's my breaking point in the next example? Perfect. Plug in your points, fill in your table. So x values less than -2, get x plus 2. So -4 plus 2, -3 plus 2, -2 plus 2. 3x gets x values greater than -2. At the point -2, 0, will my point be open or closed? Good. At the point -2, -6, open or closed? And then you have -1, -3, and 0, 0. Domain and range are both what? All reals, exactly. Both of them are all reals because every x is included and the blue graph goes down, purple graph goes up. So my range is also all reals. Is it starting to click? Good. All right. It's always the same questions. Where is my breaking point? Yep. So some of you asked, can you do your table in like the opposite order? So like start at 2 and then go to -2. That's perfectly fine. You just, like I said, have to pay attention to the equation. So x values less than 0 would be the blue, because that's the negatives. X values greater than 0 are the purple, because they're the positives.
4 minus 2 is 2. 4 minus 1 is 3. 4 minus 0 is 4. Negative 2 times 0 is 0. Minus 2. Negative 2 times negative 1 is 2. 2 minus 2 is 0. And negative 2 times negative 2 is positive 4. Minus 2 is 2. Yeah. So 0, 4, open or closed? Yep. So x values greater than 0 are going down through my points. So that's why I have trouble doing. I like to go from the negatives to the positive because I think it makes more sense with my arrows. But again, it's not wrong, so I wanted to show you. And then the blue at 0, negative 2, open or closed? Open. Negative 1, 0. And negative 2, 2. Again, this one, the domain is all reals except what number? What value does not have a closed point on it? 0. Because it's not included in either graph. So x equals 0 does not have a solution. So your domain is all reals except x does not equal 0. And your range is all reals. Because blue goes up, purple goes down, and they overlap. Yes. So for homework, I want you to do the front and back of that next page. The front is graphing. The back is writing your equations. I'm sorry it took so long to go through. You